Hi viewers, welcome to the next section of the course, the storage, Apache Cassandra. In this section, we will be learning about NoSQL, Apache Cassandra installation, and backup and compression. Then we are going to explore about the recovery technique with DBMS optimization, Bloom filter, and more. And lastly, we will explore about the Spark Cassandra connector. Now we move on to the first video of this section that deals with NoSQL. This video is targeted at NoSQL and its data model and Brewer's theorem. NoSQL is a distributed database with an emphasis on scalability, high availability, and ease of administration, the opposite of established relational databases. It is not a direct replacement for RDBMS, but an alternative or a complement. The focus is in avoiding unnecessary complexity, the solution for data storage according to today's needs, and fixed schemes. Due to its distributed nature, cloud computing is a great NoSQL sponsor. Let's learn about NoSQL database model. It is key-valued or tuple-based. For example, Oracle NoSQL, Voldemort, Amazon Dynamo, GitHub, and etc. Next is wide row or column-oriented based. For example, Google Bigtable, Apache Cassandra, and Amazon SimpleDB used by Amazon, Google, etc. Document-based. For example, Lotus Notes used in various financial and other relevant institutions such as the SAP, MTV, and SourceForge, etc. Object-based. For example, NEO used by Siemens, China Telecom, and the European Space Agency, etc. Graph-based. For example, FlockDB used by Twitter, Ericsson, and Siemens, etc. Lastly, it is XML, multi-value, and others. Here we have a comparison of the data models, where RDBMS has relatively affordable qualities. NoSQL or SQL. Basically, it depends on the application's needs. If consistency is essential, use RDBMS. If you need high availability, fault tolerance, and scalability, then use NoSQL. The recommendation is, in a new project, evaluate the best of each world. It doesn't make sense to enforce NoSQL where it doesn't fit, because its benefits, scalability, read-write speed, in entire orders of magnitude, soft data model, are only conditioned advantages achieved in a set of problems that can be solved. Consider using a NoSQL database only when you decide that this is a better solution than SQL. The challenges for NoSQL databases are elastic scaling, cost-effective, simple, and flexible. Let's learn the Brewer's theorem. In 2000, in Portland, Oregon, the United States held the 19th International Symposium on the Principles of Distributed Computing, where the keynote speaker, Eric Brewer, a professor at UC Berkeley, gave a speech. In his presentation, among other things, he said that there are three basic system requirements that have a special relationship when making the design and implementation of applications in a distributed environment, and that distributed system can have a maximum of two of the three properties, which is the basis of his theorem. These are the three properties. The first property is consistency. This property says that the data on one node must be the same data when read from a second node. The second node must show exactly the same data. There can be a delay if someone else in between is performing an update, but there can't be a difference. The second property is availability. It says that a failure on one node doesn't mean the loss of its data. The system must be able to display the requested data. The final and third property is partition tolerance. It says that in the event of a breakdown in communication between two nodes, the system should still work. It means that the data will still be available. That's all about the theorem. In this video, we have learned about NoSQL. Awesome!